Good afternoon, everyone, and welcome to our first in a six-part training on creating R Shiny applications and dashboards. This series will take you from R Shiny basics to building dynamic dashboards, interactive tables, and visualizations. I would like to thank the Bureau of Justice Statistics for their support, which makes this training possible. I want to welcome our presenter, Dr. Robert Ashmead. Dr. Ashmead is a senior statistician at NORC at the University of Chicago. He has over 10 years of experience in official statistics and public health. His expertise includes survey design and estimation, statistical disclosure limitation methods, interactive dashboard programming, and causal inference. He has worked in several areas related to public health, including substance use, maternal health, and quality improvement science. If you have a question today, you can go ahead and enter it in the Q&A, and we'll get to you. At the end of today's webinar, we will have a brief survey. Please take a moment to provide us with your feedback. Your opinion is important to us, and it helps us meet our reporting requirements. With that being said, we have a lot to cover, so I'm going to turn things over to Dr. Ashmead.
Thank you very much. Hi, everyone, and good afternoon, most folks. I first want to start with thanking JRN for the invitation to talk to you all today and to teach you a little bit something about R Shiny. To start with, let me share my screen here. If you haven't yet, I'm thinking of this as being interactive. So I've prepared a bunch of examples, and hopefully you all can follow along while we're going through them as well. If you have not yet, there is a link to this GitHub page where we have the materials currently. If you go to that, the easiest way to get the materials from there is to download them as a zip file and unzip them in your local desktop or local computer to follow along. So I'm going to be using those today as we go through. Just to reiterate, if you have questions, I'm going to try to monitor the Q&A as well as I think a few other folks. So please, if something doesn't make sense or we need to slow down and go over something, I'm happy to do that. So please feel free to put something in there. Okay, so without further ado, so I'm going to be, if you've downloaded the zip file of the materials from the web, so I'm going to be actually be going through these session 1 slides.html as the document. So I'm going to open those up. So that's going to be our starting point. And so these are HTML slides. I think one of the later sessions in this series, we're going to talk a little bit about producing documents, reproducible documents using R. So something along these slides, but I use that process to make these slides, which is a nice way to incorporate code and content when you're doing this kind of thing. Okay, so let's start off just with a little bit of an understanding about what R Shiny is and why use it. So you all are probably familiar. There are several different softwares you can use to make things like dashboards or interactive apps. R Shiny is one, along with the common ones like Tableau and Power BI. I think what really differentiates R Shiny especially from Tableau and Power BI, is the fact that it's open source, meaning it is free to use and free to program, and it's code-based, meaning that you're actually writing code instead of point and click, which is a lot, not exclusively what the Power BI and Tableau are based around, but those are more kind of point and click, drop down kind of tools, where we're going to be writing actual code. And those can be, and along with those, one of the beneficial things about R Shiny is that we can actually harness R for computing and doing kind of more complex statistical things in the background. as well. So I think compared to Power BI or Tableau, if you were interested in running, complex models behind the scenes of the dashboard, really you're only limited by what R could do, which is a nice feature. Um, and then customization. So, there are a lot of things you can do with Power BI and Tableau, but to some degree, you have a limited set of things because of you're selecting from a drop down. So there's a fixed amount of things you can do there. The way I think of our Shiny, it's a little bit broader, and you're really only confined by your own creativity and programming skills. So you can make really complicated things. There's all kinds of people make, computer games, and there's all kinds of different things you can do with this. Um, and as you get more complicated and more customized, you may have to use a little bit of HTML or CSS, but you can do a lot without those kinds of things. So it provides that level of customization that those other softwares can't. And also, going back to the open source, the costs of some of those softwares can add up quickly for organizations or for persons. So the fact that R is open source and free can be really nice in a lot of circumstances. So just to kind of start us off about like what does this look like? What are the possibilities? I'm going to show you two examples. The first is something I actually worked on um, in my previous position um, at the Ohio Colleges of Medicine Government Resource Center. This was a dashboard that was built to show the outcomes from a survey called the Ohio Pregnancy Assessment Survey. And it allows different questions from the survey to be get estimates about over time. The survey has been running for a number of years. Select different years, select different counties, compare the results by different groupings, being able to output the data in a table, download these things, really nice features. And all at the same time, this data is not publicly available. So it's also doing some disclosure things on the back end where it's implementing some rules where if there's too few persons in a particular cell, it won't output that. So it's a nice way of being able to output the data where still not giving people access to the actual underlying data at the same time, but allowing a nice intermediate way for people to use it. So that's one example. The other example I'm going to show, I did not work on, but some of my colleagues at NORC built this. And so this, my understanding, this is taking public information about crime reporting and putting it in an R Shiny dashboard, doing things like comparing over time for a bunch of different cities. And counts. I think this is actually sorted. I'm not sure how this is working on the back end because I didn't work on this. But there are potentially, there's these different pages. They might actually be slightly different dashboards functionally, but all running in R Shiny. So just to show you a little bit of the kind of the cool things you can do with that. So, oh, I think I Okay, so our Shiny hasn't been around for that long. I guess close to 15 years at this point, back from 2012. Something that was developed by RStudio and Posit by one of kind of their developers that's been there for a long time named Joe Chang. Um, and if you are a Python coder developer, there is also a version of Shiny that's called Shiny for Python that's relatively new. So you can also code Shiny applications in Python if that is of interest. And then the last thing, this R Shiny package gets updated quite frequently. I am using the latest one install that was released in December 2024, but it shouldn't make a big difference if you have a slightly older version of the package. Okay. That our plan for today is that we're going to start off with reviewing some helpful R concepts that are going to um, kind of be related to how we're going to use R Shiny and build dashboard applications. Then we'll talk about some of the basic pieces of a dashboard app, and then go through some of the steps for building an application. Okay, so there are a couple things that I want to kind of go over in terms of our a review of some R basics. The first thing here is just a reminder about pipes in R. So if you haven't seen these before, if you have to string together multiple operations or functions in R, it can look really ugly. Say we have three separate functions we want to apply to our data consecutively. Because of the parentheses you have to use in R, you have to kind of wrap it consecutively in all these parentheses. That can get really ugly over time, especially if we have other inputs and arguments. Um, so pipes are kind of a nice way to show and to code doing consecutive um, operations. So there are actually two different pipes symbols in R. First, this one with the percentage sign greater than percentage sign was released first in one of the packages. And then R as a whole implemented a pipe um, that was in one of the more recent versions of R across the board. For the most part, they do exactly the same thing. Because I learned how to do pipes under the original one, I still tend to use that one. Um, so you'll see that throughout. At some point here, I probably need to switch to the official R pipe, but we'll see when that happens. Okay, so the way these pipes work is the output of one object is treated as the first argument in the following function. So in our last slide, we were saying we'll apply function one to data, and then the output of that will apply function two, and then the output of that will apply function three. This says the exact same thing. We'll apply function one to this data object. We'll kind of pipe that into function two. It really means the first argument of function two. And then we'll pipe that into function three. Some people prefer kind of trying to format it nicely where they'd actually put the data object first and then say pipe that into function one, function two, and function three consecutively. So if you see this and you're not used to using that, feel free to pop a question in the Q&A, and we'll try to make sure that's clear what's happening. But it is a really nice way to kind of organize and visually see kind of consecutive steps as they are applied to code. I'm going to be using a package in R called dplyr. It's part of the greater tidyverse universe. Tidyverse, if you're familiar with that term, which is just a series of packages that are kind of all built under similar principles. I really like dplyr because it has some really nice features for manipulating data. And the way you use it to program is a little bit nicer than what you do with base R because of the way it treats variables through what they call data masking. Typically in R, if you were referring to a variable in a data set, you either have to use this dollar sign after the name of the data set and then the variable name, or the data set and double uh, parentheses or name's eluding me, but um, close bars and then the name. And this can get really long and make the code a little bit ugly because you have to constantly put the name of the data set, square brackets there. Constantly put the name of the data set in the code, and it can just get really long. dplyr works slightly different. You don't need to put the data that you're referencing for the variable constantly. So one example, a couple examples we'll show here with what's called the iris data set. This is kind of a data set that's built in to R that's really useful for examples. I believe it's a famous statistical data set of about flowers. Um, and it should be noted if you're following along on your own, and you have this HTML open, in the top right-hand corner of these boxes where there's code, there should be a copy to clipboard for each of these boxes, and you can copy these directly into our studio along the way. So I've actually put this together so we get the code and the output in one place, but we'll flip back between this and RStudio a little bit later on. So using this dplyr library, first we should note there's this function called head. It just prints the first couple rows of the data set. This is nice for our illustrations here, so I don't have to print an enormous data set all in one place. So you can just see here, I'm actually using that pipe here. So this just says, look at the first couple rows in the data set here. We can see information about the sepal and the petal and the species of the flower. The select function. So the select function subsets columns in the data set based on the variable names. So if we said iris and then select sepal length and petal length and species, and then looked at the first few rows, we get output that looks like this with just these three columns. So that can be a really useful way to subset our columns. If we need to subset rows, we can use this filter function. So we can subset based on some condition about the data set. Again, we can do that by just referencing the name of the variable. Don't need to add quotes or reference the data set again with that data masking. So here I'm just saying filter, so subset the data set to only rows that meet this condition where the sepal length is less than or equal to 4.4. The mutate function is how we can create new variables in the data set. So the way this works is we say mutate and then the name of our new variable or overriding an existing variable and then equals whatever kind of right-hand side manipulation we want to do. In this case, I'm squaring sepal length and calling it sepal length squared. So you can see here, I get this new variable at the end of my data set called sepal length squared. And you know, that is, it looks like we're squaring correctly there. A few more functions here. One of them, important ones for us, for dashboards, is going to be group by. So this groups observations together by one of the other variables so we can apply an operation later by that group. So in this example, we're going to group by the species of flower, and then calculate a maximum within the species of the sepal length, and then take a look. So you can see here how this works is I have my data set, I group it by species, and then this mutate, which we just learned about, is calculating the max of the sepal length. And because I've done this group by first, it's going to calculate that all within species. So if we look here, this is just showing the first couple rows. They all have the same value for the sepal length max species, which we set because we've grouped by the species first. So that ends up being the same for everyone. Another thing we can combine that works a little bit different than grouping by and then a mutate is a grouping by and then a summarize. Summarize computes a summary function over a group or all rows of your data set if you don't include a group. So similarly here to the last slide, we can group by species and calculate a max of the sepal length. But here it actually reduces our data set to just one row per species with the summarize. So like the actual computation of the max sepal length by group is the same in both these examples. The difference here is that we're using a mutate, which doesn't reduce our rows down to the one per group, but the summarize does. Um, and the last one I believe we're going to talk about is the arrange function. This is just how you can sort your data set or your table rows by one or more variable. So for example, we'll take our last example where we grouped by species and we calculated the max sepal length, but we're going to add one more step afterwards where we're going to sort it by that same sepal length. And you can see here, I've actually added one more piece in here, this DESC for descending. So normally if you just do arrange, it will sort it ascending, but if you want it descending, you would just add this extra piece in there. So we get the same output here, we just get a different order. Okay. Before I move on, I'll just pause for a second in case there's any questions on any of those. Okay. So one thing that becomes more important or more useful when we're working with R Shiny and dashboards is actually writing your own functions. Now, I know this, if you are kind of on the newer side of R, this is maybe something that you don't have a lot of experience with. I tend to find that it's kind of a more advanced piece of it's not typically taught along with some of the R curriculum, but it's going to be really useful for us because what's going to happen in the dashboard is basically we're going to have inputs, we're going to have user selections, and those inputs, we're going to do some calculations about them, and we're going to have some sort of output that is going to be shown in our dashboard. That is basically a function, what we're describing. So being able to kind of turn those inputs, combining it with the data, and outputting information, a plot, a table, etc., is going to be really useful to use the tools in R to make your own functions. So just a kind of a brief overview of some of the components of that in terms of writing our own functions. So the first thing we'll start with is what you might call arguments or inputs. So these are the things that you would define the function by. You can have functions without any arguments, meaning there's nothing that changes. It just does the exact same thing every time. Assuming there's no randomness in it. But generally, you have one or more arguments in your function. These can take a couple different flavors. It can be given a default value in the function or be undefined. The difference is that undefined arguments must be given a value when the function is called, or it will throw an error. If it has a default value, the function will run with that default value, even if you don't call, even if you don't write the argument in the function. But arguments with default values can also be optionally changed. So let's take a little bit of an example. Um, so, so I'm just going to write this little function here called fun1. To do this, I just say this is a function. Um, our input, our argument here is text. So this is a function of text. And all I'm actually saying to do here is print text. So if I were to call this function and say hello world, that hello world takes the place of text here because there's just this one argument and it will print hello world. I can also call this, it'll do the exact same thing if I name the input or the argument. If I say text equals hello world, it's a little bit more specific of what that hello world is supposed to be. You can imagine if we had multiple arguments or parameters or inputs, it helps to clear up what exactly you're doing with your code. Um, we can also specify a default value. So instead, so here we just said this is a function of text here. Now we're saying it's a function of text equal I am a default value as a string, and we're printing it. Otherwise, exactly the same thing. Now, if we call that function, because we've given a default value, we don't actually need to supply anything here to text. It will print it no matter what. Or if I supply it with an argument there for text, it changes the default value. So just something to be aware of when you're setting up these functions. Sometimes you want to use a default value. Sometimes you want to force the user to have to supply something. Just depends on what you're trying to do with the function. Okay, so we've made really simple functions there. We actually haven't used one component of a function called the return piece. So when you're within a function, the thing you want to give back at the end, the output, best practice is to actually have a return function. We'll see an example of this in a moment. And so whatever you want to you send as the output, you put in this return function. You are only allowed to put one object in the return output for a single function. You can get around this by putting multiple objects in a list, which then counts as a single object. If you don't use a return function, the last object in the function gets returned as the output. So usually if you see a function that doesn't have a return, that what it's doing is if you look at the last line of code that gets run in the function, that is what is actually getting output. Okay, so we're going to write a more complicated function now, kind of putting all of this together. And I'm also going to show a little bit downside of this dplyr syntax when writing your own functions. You have to use slightly different syntax when you're kind of you're trying to reference a variable that is an input to your function. So what I'm doing here is I'm writing a function called average by group. And I'm saying this is a function. The inputs are data. I'm assuming this is a data set. A variable group. So this is going to be the name of a variable we want to group by. A variable outcome. So what is the outcome that we want to compute this average over? And then I'm also going to put a rounding digits input that will tell us how much kind of the precision of the estimate that we want to make. And we'll give that a default value of 2. So if we don't enter that in, it will always use 2. But these three arguments don't have a default value, so it will force the users to fill those in, or the function won't work. Okay, so in this function, the first thing I'm going to do is I'm going to make a new variable name for the new variable that we're creating, that is the average by the group. And so I'm just making that name a text string that says mean underscore whatever variable outcome name we give it. So if I was computing, um, we're going to use the iris data set to give an example in a second. But if I was computing the average sepal length, and I gave it the sepal length as the outcome, it will just say mean underscore sepal length. Okay, so the next part is I'm going to string together a couple of these dplyr verbs to do this computation. So I'm just naming this out as my kind of personal way of telling myself what the output is. So I'm taking the data, I'm grouping by the variable we determined in the input to be the variable group. So this is going to be um, a text string. So we have to do something a little bit special with these dplyr verbs to name a generic text string in here, because if you recall, it's used to seeing code that's not surrounded by quotations, so not in a text string. So to get it back to being able to do that, we have to do something a little bit special. And to do that, we use this syntax where we say dot data, square bracket, the name of the variable. So this dot data actually refers to whatever data set we're working with at the time. So it's a way to kind of tell it a variable name as a string, but in referencing the data. And then so we're grouping by that grouped variable, and then we're going to summarize. And to name a new variable, also with a name that is a text string, we have to use this other syntax where we separate it on the left-hand side of the equal sign by 2 brackets on both sides. So that means replace the name by the text string, and then we're just going to take the mean of the variable, and then the next step is just a rounding step. I'm replacing that variable with another computation that just takes the output and then rounds it according to the digits. And the last step here is we're going to include a return statement. So we're returning this output, which we just computed. So I know that was a lot probably, and there's a lot thrown in there. So let's just look at an example here for a moment. So if we call our average by group on our data set, that is the iris data set, I'm grouping by the species variable. So that's a variable name. And I'm computing the outcome variable by sepal length. You can see here our variable group is this species column. And then we've taken the average for those across the sepal length here that we've given it. And you can see this variable that we've created comes from this paste operation, which just stuck mean underscore before the name of it. We didn't give a value for the rounding digits here, so it used a default of 2. But if I did the same thing and I told it round digits equals 1, we get oh, this does not look right. I'm not totally sure what happened here. Oh, I see. Um, I use sepal width instead of sepal length. We get the computation rounds to a single digit here instead of 2 digits. Okay. I want to pause again, see if there's any questions or clarifications about writing our own functions or any of that dplyr syntax that we just introduced. Okay, so that was our little review of R, some basics, and now we're going to move back into Shiny. Okay, so let's talk about the basic parts of a Shiny app. So there are some parts of the Shiny app that are going to be mandatory and some that are going to be optional. The two mandatory pieces are called the UI and the server. UI standing for user interface. That's going to be the part of the code that controls what the app looks like, where everything is located in the app, on the screen, kind of the visuals of everything. The server is the part of the code that handles the user selections, dynamic computations, anything that's kind of on the back end with R processing or controlling changes in the computations is going to happen in the server. Um, so those are the two mandatory pieces. There are also two optional pieces. There's a what's called a global file or function in the code. This is something that I like to use personally. It's something that gets run once every time the app is started up, and I use it for things like loading the data, setting parameters that would be used throughout the dashboard or application, and things that basically just need to be done once and then can be used many times over. So that's a global file. There's also something called the www or World Wide Web file in your app. This can be useful to store images or other files that your app uses. The one special thing to keep in mind about what goes in that folder is that if your app is hosted on kind of a public server, people can access whatever is in that folder directly outside of your app. If it's not obvious what's in there, but if they knew what was in there, you can look at it on the web, and that's where the name of that comes from. But that will be down the road. We'll stick to the basics and the global file for now. Okay, so we're going to start off with our first example of an R Shiny app. And we're just going to start with a UI and a server. So the UI and the server that we talked about here, they reference either files that are specifically called UI and server or pieces of code um, that take the place of the UI and server in a different setup, which we'll talk about after this. But here, these are literally called the UI and server.r. The other thing I've made here is a little bit of just something that'll help us run the code. That you'll see this run underscore example one. So here I'm actually going to go to the examples. So if you go to the materials for today's webinar and under session one and examples, this will be example one multi-file here. And so the same information that is here in the slide is going to be in this code. I'm actually going to open all these up, and I'm going to open with RStudio for the first time. And open. Okay, there we go. I made this larger, the text larger here, so everything's a little bit crowded, but if this isn't big enough, just please let me know in the chat or the Q&A. Okay, so I don't want to worry too much about what's in the code at this point. We're just mostly going to run this and then take a look at what's there. So in order to run this, one important thing about kind of all of this is the paths. The working directory for R has to be correct for this to work. So it has to know where to reference. So one important thing for all of our examples today, we want the working directory to be the directory where the individual code is located. An easy way to do this that I like to use is if you actually right click on, for example, these run example. One, you get this set working directory option in RStudio, and then it sets that for you. And this will be dependent on everyone's different computer, which sometimes makes teaching these classes tricky because of different paths on everyone's computers can be different. But hopefully this works for everyone. Okay, so once we have that, I am just going to run these lines of code. You can press this run app. I usually highlight the lines of code and run them with the keyboard shortcut. Typically, the keyboard shortcut is Control Enter or Apple Enter, depending on your interface, and we get our first dashboard here. And this is a very simple dashboard. We just have a message box here that we have says hello JIRN, and we have an output, but we can change this. So in our app, let's spell this right. We have an interface that shows us both, that lets us input a message and it outputs the message. So this is very, very simple. So you can play around with that. There is a little bit of latency between what you type and what appears, but it is pretty good. So by default, if you're using RStudio, it's going to open in an RStudio browser tab here. We can also open it in whatever browser we're using, which I think looks little nicer. So we're going to tend to use this instead, but this will work the exact same way. Okay, so let's take a little bit of a look of what's going on there in the code. So if we were to match up exactly what's there, so in our UI.R, so we said this is controlling where things are located in the page, where our output is. So we say hello world. We have what we'll talk about a little bit later, more specifics, text input. You can see here the label is type a message, value hello JIRN, and then we output a message. So if we go back to here, we see hello world like we had there. We see type a message, that was our label. We had this box here, which was our input, and then we had our output. So hopefully you can see the correspondence between what is in the UI.R and what is in the output there. In the server, don't worry too much about this at the moment, but what we're actually doing is we're taking the value from our text input and we're simply outputting it, we're rendering it, and then we're sticking it back on the page. Okay, we got one question from someone saying they don't have a specific package. Or saying they got an error. Double check that you have run this library Shiny at the same time before you run app. If you have, and you're still getting the error, you may need to install the Shiny package. And this is probably a good time to point out, if you go back into the materials, kind of the base of the materials, there is this file called packages to install. If you haven't done this, that's the wrong R. If you haven't done this yet, these are some of the things we're going to be using. Doesn't want to open for me. Oh, I have to stop this. Okay, our dashboard was running, so it was getting a little mad at me. Apologies. Okay, if you haven't yet, these are a bunch of the packages that we're going to be using today. I will note that I did add, I think, 2 versus maybe what's on last minute relative to what was on the website. So you may want to rerun this anyways, but Shiny should be in there. So hopefully that works for folks. Um, I don't know, is there a way, do people able to give like a thumbs up if they were able to run the dashboard or some other indicator? Maybe not on this interface. Okay. Um, okay, so where were we? Okay, so that is our first live example of an R Shiny dashboard. And okay, so let's move on. So that was if we have multiple, we have our UI, we have our server um, in multiple questions. And we can also make the exact same app, but put it in a single file. So example two here is the similar code, but we're just putting it in a single file here. So if we open up um, example two, and I'm going to open this with RStudio. Remember to set the working directory here, though I don't think that makes a huge difference for this particular one. And I run this code. I get the same exact app we were just looking at. So if we look at this a little bit more closely, what we have instead of different files is I have an object that is the UI. I have an object that is the server, and then I tell them to my Shiny app what is my UI and what is my server. So it works similarly to having separate files. It just is all in one place. So there can be benefits to that as well. Um, Let me stop this and go back to our slides. Okay, so we just said we could have single file apps versus multi-file apps. I tend to work with multi-file apps where we have these separate UI.R, server.R, and global.R files separately. Um, my rationale for that, for when you start to build real applications in progress, it gets kind of complicated to organize all the code that you have. So having the code in different places rather than one enormous file has some real advantages in terms of keeping track of everything and understanding where to find different pieces of code. But if you have kind of a smaller or a test application, you can use that single file application kind of method. And one benefit is that you can name those UI and server functions anything you want, versus when you have them in this multi-file app setup, it has to be named UI.R and it has to be named server.R and it has to be named global.R. R is actually looking for the files that are named those things when it runs the dashboard. So that is an important thing to make sure for when you're building your apps. Okay, so those are the individual pieces. Any questions about those, about the UI, the server? Okay. So let's get into building an app. So I'm going to give you all the basic outline here. It's going to go like this. We're going to first load the data in the global file, which we just talked about, and do any pre-processing of the data that we want. Next, we're going to add user input widgets to the UI. So these are going to be the things that select the year of the data or what variable or the text string which we were outputting. So those are going to be the input widgets. Then we're going to move to the server. We're going to combine those user inputs with the data sets that we have to produce outputs. And we're next going to place those outputs back in the UI. The last step we have is to add layout and design features to the UI. We're actually going to talk about this in our next session in 2 weeks, but we're going to focus on steps 1 through 4 today. So let's start with a motivating data set. So um, to find an applicable data set for you all, I found this Florida criminal history data set that was publicly available. I don't know if we have any folks from Florida here today, but on their website, at the link here, if you go down to the bottom and under full data set download, if you click on the CJDT master download of all Florida convictions and download that, go ahead and do that. It may take a minute. It's going to be a zipped file, and you're going to want to unzip it. And I didn't put this in the actual downloaded resource file, but what you're going to do after you download it and unzip it is I want you to put it back in the materials within data. It should be this file called Florida Convictions. And what it should look like is actually 14 different files that are CSVs of our data set. And so I'll give folks just a moment to do that. Again, if you go to the website, under full data set download, the CJDT master, and that will produce a zip file, which we can unzip and stick in this folder. And I'm assuming everyone's going to name it the same, or not change the name of the folder that it comes in, else our test code might not work quite as well. Okay. So let's take a look. So I am going to use this. One thing I've run into when teaching some of these kinds of courses is one thing that comes complicated with R is these paths. Everyone has different paths on their computer. So I am going to try here using this R package called here. What this does is tries to standardize paths based on an R project. So if you look, sorry, wrong shortcut key. If you look in the materials, there's actually this file here called jirn.rproj. So when we have it, if this is working correctly, what R is going to do is see where that lives for everyone when we're within a subfolder of this, and it's going to base all our paths off that relative location of that. So hopefully that's going to work okay for people. And if you haven't installed that, if you do install.packages here, you'll get that. I'm also using this package here called Reader to read these CSVs. This works a little bit faster than the standard read.csv function in R. And this is actually a relatively large data set. And so reading it quickly is helpful for us. So we're going to read that in. We're going to say read underscore CSV. This here data, Florida convictions underscore 0000 is we're just going to read in the first file here to take a look. And we have the file has these data names here. We have state, sex, age, arrest, prosecution, offense, and degree, all kinds of things. that you all are probably more familiar with than I am, but we're going to use this for our examples. Um, in this particular data set with the single year, the single file, we can see we have arrests from 2014 to 2018. If we print out the individual row, we can see this is individual level data. And so you can see things like, the state, the county, the sex, race, age at time of arrest, arrest date, those kinds of things. Um, if you are interested kind of at some later point, I did also, let's see. Oh yeah. Include code to load all of the data at once in our dashboard. It does take a while longer, so I don't want to use that for examples. But if you look at this next slide here, this is how we're actually going to load our data into when we build this global file. So our first step is loading the data in global. Um, if we really wanted to read in all the rows, I put commented code here, which should work. It first lists out all the data that's in that folder and then reads it in a loop. So it's actually, if you were to read in all those files, it would be 12 million rows of data. So it's actually quite large. But so we're just going to use a piece of that for our examples today. Okay, so that's going to be our global file. And we can even just do this quickly in R. I didn't make a separate file in our notes, but we'll have one when we move to the next step. So you can see it takes a second to read it in, but then we have our arrest data. Okay, let's move on to the next step. Okay, so the next thing we're going to do is add user input widgets to the UI, allowing the user to interact with the app. This code is going to belong in the UI file, except we'll get into some later examples where input selections are actually dynamic, and things that are dynamic actually have to happen in the server. But that is a more complex example we'll get to in a little bit. So let's take a look at example 3. So I'm actually going to close down some of these so we don't get confused. So if I pull these all up together, remember to set the working directory for the run example3 file. And then if we run this, this isn't going to be based off our data at the moment, but it's going to give us some examples of these Shiny inputs. So things we can do, we can have a drop-down menu with some different options. We can have radio buttons. We can have sliders. We can have numeric inputs where I can either use the up and down arrow or I can enter numbers. I can have calendar date ranges in different widgets or a single date. I can have a text input value. That's what we used in our Hello World app. And I can also have checkbox input. So this isn't doing anything at the moment. We're just showing the different widget components. But let's take a look at what the code is that does this. So to make so we can glance at it first in RStudio, in our actual file. So you can see here, don't worry about these choices or this fluid page at the moment. We'll just assume that's kind of how we have to set up our UI. But you can see we have something called select input, which is the first thing, which was our drop-down menu. We have something called radio buttons, slider input, numeric input, date range input, date input, and so on in our UI file. In our server file, we don't actually have anything in there. It is blank. We always have to have this input and output in our server file in this structure, but we're not actually computing anything. So there's not anything in there at the moment. If we go back to the slides for a moment, what we have here, I just want to walk through how some of this works. All right, so this first thing we had here, there was that drop-down menu called select input. The what you put when you put this in the UI, there's a couple options, arguments for this particular function. The most important probably is this one called the input ID. So we're going to have a bunch of widgets in our app, and we're going to do some computations with them, and we need a way for R to understand what widget or which input you're talking about. So this is how R keeps track of it. So input ID is a text string that it uses to track what that widget is and to take the input from it. We have a label. That's what gets shown on the UI. Select input. We have our different choices that were in our drop-down menu. We have a selected choice, which is the default choice it starts with. And we also have an option whether you want to allow them to select one choice or multiple choices at the same time. Radio buttons, similar thing. Input ID, we have a label, we have choices, we have selected. It's not important that you can memorize all these different options for the widgets. The important thing is understanding the structure and the options. We always need an input ID, and then the other pieces are pretty standard names of options that you'll see are the same across these other ones. So for our slider input, again, we have this input ID, we have a label. Here we have a min and a max for that slider that we looked at, and a default value. For our numeric input, that was this one here, where we could go up and down or enter a number. We have an input ID, a label, a value, and then a max. Our date range, this is where we had two dates in the calendar function. Same thing. We have the input ID, label, start, end, min, max. Similar with the date input, just less in terms of the start and the end. Textbook input and checkbox. So the big thing I want to get across, input ID, all of them have a label. Most of them will have, I think all of them will have a value. Maybe not all of them. Most of them have a value. But understanding the components of these, and they'll have one being able to look up what you need in terms of a widget, and then using the different components. So key aspects of this, we've talked about this input ID. These need to be unique used in your app. Otherwise, you don't know which widget you're talking about. So the most important thing is that to use descriptive names of those and to make them unique so you can better identify them. In the other component, when we string these together, this is our actual UI that we were looking at before. We're going to separate UI elements by commas in the script. So we're going to start off with this thing called fluid page. We'll explain more about that later. But we have examples of Shiny inputs. This is just a text string. But here are our widgets. So we had our select input widget. We put a comma after that. We have radio buttons, comma after that, et cetera, to the end when we wrap it in the commas. Okay, so let's take what we just did there with the inputs and think about this for our motivating example. So we want some inputs based on our data. So I decided that we should have a drop-down menu for the year of the arrests and a selected outcome, um, a variable to analyze. I just picked a couple of the choices, sex, race, prosecuting offense, grouping, and degree. Um, excuse me. So to do that, I'm going to use this select input. I'm going to call my input ID year here, and I'm going to give it a label of select a year. I'm going to tell it the choices. These are the same years that were in our data set. We only are going to allow the user to select one of them at a time. And then our selected outcome, also going to be a drop-down. We'll use this a lot. We'll give it a unique input ID, selected outcome. We'll give it a label, choose a variable to analyze. This choices is just a text concatenation of a couple options. We'll give it a default option under selected, and we'll tell it we can't choose multiple at a time. So let's open that example 4 up and run it. Okay. We don't need to look at all the pieces. The most important one is just the run example 4. Make sure to set the working directory and then go ahead and run it. Oh, got to make sure we stopped our last one. Okay, so now what we see is we have a our drop-down menu of the years, and we have a variable that we want to analyze. Now, nothing happens when we change this, and that is because we haven't set anything up on our server to actually do any computations yet. All we have is, this is our old one, is the components in our UI. So we can select them, but nothing is happening. Let's go to our next step. Oh, one thing before we move on, I'll just call out there are other widgets you can use. This is a nice reference for all the different widgets that are like the base R Shiny widgets here in this widget gallery. There's also a separate package called Shiny Widgets, which gives some additional ones. Let's see if they have the options. They're down here, but these ones kind of look a little bit prettier. Some have some nice additional options like a select all and a deselect all. So I will use these sometimes as well. So just know that there's a couple other options besides the ones I just showed you in terms of what the input widgets are. Okay, so let's go move to step 3, which was in the server. We're going to combine the user inputs with the data to produce outputs. So the server is going to use our data, which we created in global, along with our inputs, and we're going to produce our outputs. The way we actually access the inputs that we are making with the widgets is we use the name of that input ID that we put in our UI, and we say input $, the name of it to reference what its value is at the time. The other key component which we're going to use, which is to create outputs, we're going to use a function from the render family. These are we'll see in a second examples of this to assign an output object with a unique name. So just like we needed a unique name for the inputs that are going in our widgets, we're going to need a unique name for our outputs that are created in our server. So we're going to use this output $, some unique output name for those. Are examples of render functions. So these are going to pair with things we want to do. So we have a render plot, we have a render table, render text, render image. The other key component of this is you use a parentheses and curly brackets when you call these. We will get some other render functions, which will go with specific other output for more advanced mapping and plots, which we'll use down the road as well. Okay, so let's go back to our motivating example. We're going to put this together a little bit more. Okay, so in our global, right, this is the same information we had before. We're just reading our data. This is the same code. Our UI, we still just have our select inputs, which are our shiny widgets. And the next part is our new server code. I forgot that I put this on a separate slide. Okay, so our new server code, we're going to do a couple things here. We are going to have a little bit of a text string that just tells us what our input options were. And then we're going to have a table that does some computations based off our input. So let's actually look at our example of this, and then we'll look at the code. Just close some of these down. So I'm going to go to example 5 with the server. I'm just going to open up this run example 5 for the time being. Remember to set the working directory, and then we'll run this. Okay, so now we can select things, and we can select analyze. However, there's one problem still. Okay, so we have server code that is doing things on the background, but we haven't outputted again. So we're actually not expecting anything to happen here. So let's take a look at the code that we're actually using. So in our server code, we actually are always going to have this function input output. That's just standard. Always put that there. The things we're actually going to output, we use this name output to start and then $sign. So we want to output this object, which we're calling text selections. And so from that, we are making a text string where we're just going to say, you have selected the input year, which is coming from the year select widget, which we just put here. This input ID is going to match this input here. And the selected outcome, which is coming from the other input ID, selected outcome here, selected outcome with our input. So that's just going to spit out a text string to tell us what we selected. And then we're also going to use those to create a table. We're going to use our arrest data, which is what we made in global. So anything that we make in global is going to be available in our server function. So we said arrest data was just what we read in. So we're going to say arrest data. We're going to filter the arrest year to the input year. So again, we're using this. This is going to get replaced with the actual year that the user selects. And then we're going to group by the selected outcome that we put. And so again, this is that kind of data masking thing that we were doing in the beginning examples. We say dot data just generically, square brackets, and then the name of the variable that will be passed to it from this input selected outcome. Again, the same thing we were doing in the text. It's just going to be used here in our data. And then we're just going to count these things and arrange them. So again, we can't see the output of that at this point. So the last thing we need to do is we need to place the outputs in the UI. So each render function that we have actually has a paired output function that we use in the UI. So when you do a render a plot in the server, you do a plot output in the UI. If you do a render table, you do a table output in the UI. If you do a render text, you do a text output in the UI. Render image, you do image output in the UI. So you get hopefully get the picture. Um, in the output function, we reference the unique output name we created in the server. So in the case of our example here, we created these unique names, output $ text selections, output $ output table. Those are the things we're going to reference when we use the render text to tell it what things to look for when it's rendering. So the last thing we're going to do in our example here is we are going to add the output to the UI. So I'm back in the UI.r file. And so below all of our widgets, all I'm going to do is I'm going to say text output, our text selections, and table output, our output table. Again, those are coming from these names right here in our server, text selections and output table. Text selections and output table. That is all the additional code we've changed for example 6. So let's go ahead and take a look. And again, I got to make sure to stop the previous app, set the working directory. Aha. Okay, so we finally have some output. So this is exciting. Okay, so we have our selection year. If we change the selection year, the table output changes, as well as we have this text string here, which just says repeats what our inputs are. So we can look at the data, just counting the sex groupings or the race groupings or these different offenses. There's a lot of these different categories here, actually, or these smaller groupings or the degree. So we finally have a little bit of output here. So this is exciting. And one additional thing, if we look back at these drop down labels, these are literally the names of the variables in the data set, which may be useful for some people, but it doesn't always look the best. So one thing we can do is we can tidy that up slightly. We can map kind of user-friendly names with the underlying variables by giving basically our choices different names. So the way we would do that is we add labels to the vector that we're using. So the first item that we're giving in the list is the label, and the second is going to be the underlying value, which we're going to use to reference the data set. So I can say, nice names, prosecution offense instead of pros offense, prosecution groupings, so on and so forth. So that just makes it look a little tidier. And if we go to example 7, we can take a peek at that. So yeah, all the difference is we see our nice labels here instead of the actual variable name. So the way to think of it is we select the label corresponds to that underlying value. That underlying value is used in the back end of the server in actuality. Okay. We're going to do one more thing in this last example today. So we're going to add an optional percent column. So Our table just has counts of stuff, but it is sometimes nice to also have calculate the distribution and the percent in each of the category. So that's basically what we're going to go for. So we're going to use a checkbox widget to give the user an option to include a column in the table that computes the percent of the rest in the category. So how we're going to do this, we already have our app. So we're kind of go back through the steps slightly, which with the ones we need. First, we'll add the widget to the UI. Then we'll use the value from that widget in the server, and then we'll output the value in the UI again. So as a reminder, the UI code for a checkbox looked like this. We had checkbox input, um, input ID, label, and then the value is either going to be true or false for a checkbox. So let's take a look at that for example 8. And I'm actually going to open all these files up. Uh, Apparently I didn't reset the working directory. Okay, there we go. Okay, so we have a checkbox. When we click on it, we get this extra column in our output data. That is the percent. We can click on something with a smaller number. Hopefully these are computed correctly, but that's the only addition. Let's take a little bit of a look at the code that is creating this. All right, so all we did for our checkbox inputs in our UI was just add this additional piece of code here. On my input ID, I called it add percent column. The label I gave it was calculate percent, and I set it for an initial value of false. Then in my server, what we did was with our render table, um, after the initial piece that we created that looked like this before, which was just the counts, I added some logic that said if that add percent column input was true. So this is technically the same thing as saying equals equals true. Um, then create a new column called percent that is the count divided by the sum of the count. And I'm rounding to 4 decimal places, then multiplying it by 100 to do the percent. So just this little added piece of code to manipulate the table um, to output the percent. And then the last piece, oh, that is the last piece because there is no changing the output because we already were outputting that table. So that the biggest part there, right, is we had checkbox input. It had this input ID of add percent column. We're using that input add percent column here, and we're putting that in our output table, which we already had before. Okay. We are getting towards the end of our time for today. So just as a review, so there are 2 mandatory parts of our app. We talked about the UI and the server. There's also some optional pieces called the global and that www directory. There are 5 main steps to creating a basic app. We talked about the first 4 today: loading the data, adding user input widgets to the UI, combining user inputs with data produce outputs, and placing the outputs in the UI. We're going to talk about this 5th step, add layout and design features, next time, and making our, the whole layout of the app a little nicer. Okay. My opinion, if you're interested in kind of diving into this, the best way to do this is put your hands on some more examples and get practice corresponding the inputs and the outputs and yeah, just uh, looking at different examples of doing this. So I've dreamed up a couple practice activities for you all to do between now and our next session if you're interested in diving into them. So these are the following. Taking our current working example with the Florida arrest data, some things you could think about doing would be to add a date range selection and filter by a start and end date. So there's a field in the data that's like arrest date as well as the year. So you could actually filter the data down into the results by a beginning and an end date. There are some records with missing values for some of the outcomes, so you could also add an option, a checkbox, for example, that would remove or keep missing values in the tabulations, because sometimes that can be nice. Um, kind of an advanced thing we could do is add an option to select a second variable that would now allow the analysis to be computed within groups. So, for example, if you wanted to do an analysis of prosecution offenses by sex or by race, you would need a second drop-down variable and manipulate that second variable as well in the data. So those are three things you could try out by yourselves. Um, a second thing, if you wanted to try building a new app based on the examples we had today, completely from scratch with a separate data set, I found a public data set here with this link um, from the Office of Justice Programs, the Recidivism Challenge dataset. So if you go here and you click export and you download this file, this could be a data file to use to look at to build an app that would calculate some tabulations based on recidivism. It looks like this is state of Georgia data. Um, or obviously, I know you all probably have data sets for your own states that you may have access with. That would be a good um, test as well. But practice um, adding these features, and then next time we'll be talking about um, additional UI. Okay. Um, so we are at about time today exactly. Next time we're going to be talking about layouts and design features, that fifth step. We'll also get into some options more with static plots from ggplot, and also talk about what are called reactive expressions for our Shiny dashboards. So I'm going to leave things there today. And um, if there are any questions, I'd be happy to answer them.
If anybody has a question, just raise your hand. We can unmute you and you can ask it. Well, I'm not seeing any questions. I just want to remind everybody to please take our feedback survey when we're done here. It would really help us. And thank you, Dr. Ashmead. We'll look forward to the next session.
Yeah, absolutely. Thanks, everybody, and looking forward to the next session.
All right. Thanks. Take care, everybody. Have a good weekend.